We're here at Achema 2012 at Invensys stand. I'm talking to Mr. Fernholz and Mr. Kovach about process simulation. Mr. Fernholz, what's the potential of product simulation, process simulation, and the simulation of engineering?
This is a very good question, and I can certainly see a couple of trends coming up in the area of process simulation. And one thing we have seen over the last, let's say, 1 to 5 years is that customers are more interested in applying process simulation and process models in an online environment. We've got a very good application example which comes from BASF. So BASF, obviously, everybody knows, is a big chemical company, a global company, and one of their key parts of each big production facility is the cracker producing the raw materials for most of their processes. So they're applying online models to these crackers in order to optimize at each time of the day, each time of the production, the yield and the economics of the operation. So the key challenge is twofold. On the one hand side, they can run this production facility with different feed supplies. So the feedstock is naphtha, so they have to purchase naphtha on the market, and naphtha comes in different grades, so they have to make a decision which grade to purchase, comes at different prices, and they can process it in different ways. So the decision is which naphtha to buy, and on the other side, obviously, the big production units have a change in demand of the material which is produced by the cracker. So there's a change in the demand for these products from the cracker. So the operation units have to make two decisions at the same time: is what's the future demand for our products and which naphtha to purchase. And obviously there's a big potential to make optimal decision in this context.
Maybe you can ask Mr. Kovach one question about process simulation.
Yes, so obviously, Joe, this is the general concept, and as one of our technical leads and technical experts on this area, maybe you can outline how this is done from the technology in terms of applying this model online.
The technology is to develop a rigorous first principles model of the plant, and then periodically reconcile that model against the actual plant conditions. So there are things that you don't know about the process, and you would adjust those parameters in the model to bring the functional description of the process into line with the actual plant. And that gives you a very accurate prediction of your yields from the furnaces, and then also your separations further down in the plant. It gives you accurate calculations for energy consumption and also product yields. It can also determine what the constraints are in the plant, which is critical when you're trying to maximize throughput and you can sell everything that you're making. BASF has looked at using the online model, this reconciled model, in an offline environment to do the best optimal feed selection, specifically for their heavier crackers. And then there are other customers who use the same technology, but they do a more simplified approach and do an evaluation of a much broader selection of feed. So the technology can be used either for the online or for an offline, and at various levels of fidelity for the process models, depending upon what the customer wants to achieve. And since this is Achema, we're also trying to push the technology into more of a pure chemicals application where people aren't using it on these very large processes, that there are benefits to be had by using the technology on small processes for process understanding and for diagnosing problems. That typically when you're doing a simulation or you're running the plant, you don't know the details about the equipment operation, you don't know the temperatures inside some of the, like a distillation tower, you don't know the profiles in the tower, you don't know internal properties of the streams. By using the online model, you can calculate all these properties periodically, say every hour, every 2 hours, and that gives you a window into the actual properties that are being produced inside your equipment, the characteristics of the equipment, the efficiencies, and inferred values that you actually can't measure. So it gives you a much better view into the process for smart operation of the process. The technology has gotten good enough that these models can be developed much faster than they used to. 10 years ago, you could only justify this model development with very large processes. Now the technology has gotten good enough that you can develop the models quickly and get good returns on smaller processes through better process understanding. Okay.
Thank you. Process innovation, I think process simulating is very innovative, and here at the Achema there are very great ideas. Is there something who can top this or make it better? What do you think? What's the future of process simulation in 5 or 10 years?
I think one of the big areas of development will be dynamic simulation. So this is becoming more and more an established technology where, let's say, the standard process engineer can use this technology. It used to be a couple of years ago a highly expertise requiring technology where only certain engineers could use this technology, and this limited its application. But I can see a trend that this is becoming more and more a technology commodity. So I expect that in 5 years' time, dynamic simulation will be a tool as widely used as steady-state simulation nowadays.
I also have a comment that on the dynamics, or not the dynamic side, but more on the optimization side, that with tools like with Romeo, people are looking at extending the models to a much larger system. The processing power has gotten good enough that you no longer need to simulate just one unit in a refinery or a chemical plant. You can start integrating much larger pieces of it, and you can go to whole refinery modeling and optimization of whole refineries. You can get one of the keys in doing the modeling is to evaluate feedstocks moving between process units. And by expanding the scope of the optimization to include multiple units, you can see the nonlinear effects from one unit to another, and you get much better evaluation, much better economic optimization of the unit. And then eventually you can take these models, their techniques, to simplify the models for even larger planning, so you can plan for entire regions in planning and scheduling. And I would say that would be coming in. Some customers are looking at doing some of that now, starting at the lower process and moving up. So I'd see that for some of the majors, you'd see that happening in a few years, and then it will move into the broader market maybe 5 to 10 years from now.
So, Mr. Kovach, Mr. Fernholz, thank you for the short interview, but it's very interesting, and maybe we meet at the Achema in 3 years with new models, dynamic models, or new ideas and innovations. Thank you.
Thank you very much.